Good morning, everyone. This is the recorded video for week 6, day 2. Just a reminder, we have office hour every Wednesday between 1 to 2 p.m. Come and drop in if you have any question. Today, we will dig deeper into the article that we saw on week 6, day 1. Let's take a look. What is one key point that you remember from the article? Let's take a look at the article to see the factors that affect climate in the past. The shape of the Earth's orbit around the Sun naturally changes over time, and so does the way it tilts toward the Sun. Many of this change happen in cycles that repeat over tens of thousands of years. This change affects how much of the Sun's energy the Earth absorbs, which in turn affects the Earth's temperature. Over at least the last few million years, this cycle likely caused the Earth to alternate between cold and warm periods. For the last few thousand years, we have been in a relative warmer periods. So right here, we can see that one of the factors that affect the Earth climate in the past is the fact that the way that the Earth orbit around the Sun can changes. If it is slightly closer to the Sun, then it will be slightly warmer, and if it is slightly farther away from the Sun, then it will be slightly cooler. Let's take a look at the second factor, changes in the Sun's energy. The Sun goes through sunspot cycles every 11 years or so. During times when there are sunspots, dark spots, some as big as 50,000 miles wide, move across the surface of the Sun. When this happens, the Sun gives off slightly more energy, which makes the Earth a bit warmer. The Sun also goes through longer terms change that affect how much energy it gives off. Let's take a look at this picture. This darker spot that you see right here, they are known as a sunspot. This spot gives off more energy, and again, as we learn about different way of how heat transfer, we receive energy from the Sun through the process called radiation. So in this way, when the Sun gives off more energy, the Earth will receive more heat, and thus it will be warmer in comparison. Next one, photosynthesis. The Earth's first billion year was very different from the condition today. The Sun was cooler then, but the planet was generally warmer. That's because there were a lot of greenhouse gas, like carbon dioxide and methane, in the atmosphere. Also, the atmosphere back then contained very little oxygen. It was a very different world, a world without people or the kinds of plants and animals that thrive in today's climate. But photosynthesis, which became common about 2 billion years ago, changed all that. During photosynthesis, plants take carbon dioxide out of the atmosphere and replace it with oxygen. Photosynthesis permanently changed the atmosphere by adding more oxygen to the air while reducing the amount of greenhouse gas. Let's take a look right here. The Earth was formed around 4.5 to 4.6 billion years ago. That is also around the time when the Sun and the solar system was formed. However, for the first section of the Earth history, there was actually no oxygen there. It was only around 2 billion years ago when oxygen is abundant in the atmosphere of the Earth. So before there was oxygen and after there was oxygen, there was a big difference on how the Earth climate was like. Let's take a look at the fourth factor, which is volcanic eruption. When volcanoes erupt, they spew more than red hot lava. They also added carbon dioxide in the atmosphere along the dust, ash, and other particles called aerosol. At certain time during the history of the Earth, some very active volcanoes added a lot of carbon dioxide to the atmosphere, causing the planet to get warmer. However, most of the time, including today, the major effects from volcano is actually cooling the Earth because aerosol blocks some sunlight from reaching us. If an eruption is big enough to launch these particles high into the atmosphere, it can lead to slightly cooler temperature around the world for a few years. So right here on the very left, we can see a picture of Mount St. Helena in 1980s. And this one right here, this is Mount Pinatubo. And on the right, this is the volcano in Indonesia. It's called Mount Merapi in 2012. So right here, we can see that they're doing two things. One, they're adding more carbon dioxide in the atmosphere, but on the other hand, they're also adding more aerosol, which is leading to a slightly cooler temperature. We can see that more obvious in the eruption of Mount Pinatubo, where you can see two layers of aerosol. Now, with that, we're going to do this interactive activity, and feel free to click on the link in the description below to find this link. We're going to take a look at sea ice, sea level, carbon dioxide, and global temperature. As we're going through each one, I want you to take a look and pay attention to what do you notice. Let's take a look. Let's go from sea ice. This is the sea ice from 1979 to 2020. What do you notice? We can see right here, this is Canada, Greenland, northern part of Europe, and northern part of Russia. And we can see Alaska right here. But take a look right here to sea ice. What happened? What do you notice? Let's take a look at the level of sea level. So we can see this is the southeast part of the United States. So we can see Miami in Florida, and we can see New Orleans right here. Let's take a look at what happened. If ice melt, we will also see that the sea level will also rise, and we can see potential flooding around the coastal region in United States. How about carbon dioxide? Take a look at the amount of carbon dioxide from 2002 to 2016. Pay attention as the time lapse goes through and see what you notice. Again, the pale yellow color is showing 300, and it's get more brighter and more vivid. We are going to the 400 region. What do you notice so far? How is the color changing? What do you think the color change means? Do you see any alarming part about the colors on the map? Which part tend to have a brighter and more vivid color? Do you think there is a reason why certain part has a more vivid color than others? What do you think? What do you see? Again, this is the change in carbon dioxide from 2002 to 2016. Last but not least, let's take a look at the temperature differences from 1884 to 2020. So we're going to go back to 140 years ago and take a look at how the temperature changes throughout. So again, you can see the temperature change, meaning blue, referring to that is cooler. And then right here, if it's yellow to red, that is referring that is hotter. So right here, this is -4 degree Fahrenheit differences, and on this side it is +4 degree Fahrenheit differences. What do you notice? Are there certain places that tends to be warmer? Do you see a difference between the land and the ocean? Or is it the same? What do you notice? Are there certain parts where temperature increase is more obvious than others? Why do you think that is happening? With that, let's go back to our slide earlier. Again, feel free to continue explore this website in the link in the description below. What happened in the past where carbon dioxide go up and down and up and down? That is true. Same thing for temperature. We also see a cycle of it going up and down in the past. However, what is different right now from the past is how high it is going up and the point of how much carbon dioxide we have in the atmosphere. In the past, although that it was going up and down, it always remains between 200 to 300 parts per million. However, today, by 2019, we are seeing an average of 409.8 parts per million of carbon dioxide. So not only are we just seeing the pattern of warming and cooling in the past, but this is actually a lot higher than what we have seen before. So I want to end with this comic right here. It is true, there are natural factors that affect climate, definitely. We talk about the change of how the Earth orbits around the sun, sunspot, photosynthesis, and volcanic eruption. They are important. However, what we are seeing right now is the man-made source of carbon dioxide emission is causing a lot more carbon dioxide than what we have seen in the past. At this time, make sure to take a moment, finish your reading, week 6, day 1 reading, and go ahead and turn it in. If you have any question, again, we will have office hour today, Wednesday, 1 to 2 p.m. at our regular Zoom. I'll see you later. Bye-bye.